Today we are going to write an equation in slope-intercept form, but we don't have the slope, so we're going to end up having to find the slope. We'll be given 2 points, so we will be able to do that. Let's take a look at the steps here to do this. We need to first find the slope of the line, which, as we had talked about before, the slope of the line is equal to the change of the y values, y minus y1, over the change of the x values, x minus x1. Then from there we're going to use this point slope formula. We're going to use just the slope we found earlier and just one of the 2 points. And it doesn't matter which point you use, because either one will give you the same answer. So we'll plug those values into our point slope formula, which is listed right here in purple. And then from there we solve for y, so just simplify. So we've got a few examples to go over. And the first thing we're going to do again is we're going to find the slope. So remember, the slope of the line is when we take our 2 y values and we write that as a subtraction problem over the 2 x values. So let's go ahead and take those y values. So the y values are -2 and 10. We're going to put those in place of the 2 y values on top of this fraction. So -2 minus 10. Now down below, we're going to take the 2 x values. So those x values are 1 and 3. And we're going to put those in place of our x values here. And so when we do this, see how I started with -2? I've got to start with the same point's x value. So I'd start with +1. So I write this as 1 minus 3. Whenever I've got a subtraction problem and I have some negatives, I always add the opposite. So -2 minus 10, same thing as -2 plus -10. Same thing here. -3 or minus +3, same thing as plus -3. So when I do the work, I end up with a -12 over -2, which, if I simplify, just equals 6. So now I know the slope is 6. And I also have 2 points. Well, all I need is one of those 2 points, and I'm going to substitute it into this point slope formula. So we'll go ahead and take the values. Doesn't matter which point you pick. I'm going to use this point right here, and I'm going to take that -2, and that's going to go in for y1. So I'll rewrite this as y minus -2 equals the slope, 6. 6 is the slope. And then x minus, now I take the x value here of 1. And again, if you used 3 and 10 in place of 1 and -2, you'd still come up with the same answer. So let's go ahead and simplify this. We're going to multiply the 6 over the x and the 6 over the -1. So when we do that, what we've got, still have this y, but this minus negative, again, you can always write minus negative as plus positive. And I'll go ahead and rewrite it that way as well on this next step. So I'll write down y plus 2 equals 6x minus 6. So from that point, just need to do one final step to get y by itself, and that is to subtract 2 from both sides. So I'll take away that 2, and then we'll have our answer. So our final answer is y equals, and then we have 6x, and then since these are the same sign, we have to add those 2 numbers together, and that makes -8. And so there's our answer in slope-intercept form. Well, we can try another problem similar to that. Here's another example. Again, we always start with the slope of the line. Got to find that first. And so we're going to take our y values and subtract them, and then take our x values and subtract those. So let's take a look at the y's first. We'll start with this 2. I'm going to put that in place of y. -23 goes in place of y1. So I write it as 2 minus -23. It's always going to be minus whatever that number is, in this case minus negative. So down below, we're going to take our x values. So x values here are -1 and 4. And take those numbers, those go in for the x values down below. And so I'll write this as -1 take away positive 4. So whenever I see that minus and then I've got some negatives, I'm always going to change that to plus positive. So plus positive, plus negative in this case. So minus negative makes plus positive. Minus positives make plus negative. It just makes the math easier for me when I go ahead and do the work. 2 plus 23 is 25. -1 plus -4 makes -5. So I go ahead and simplify. -5 is the slope. Well, from that point, we now need to find out or write down one of the points and that slope into our point slope formula. So we're going to take in our one of the points. Again, it doesn't matter which one. This time I guess let's take this one here. 4 -23. That seems like a tough number. So I'll rewrite the equation. Y minus -23 equals the slope. The slope is -5 times by x minus 4. So one of the things that people make the mistake on is they put the 4 in place of y, 1, because they think, oh, 4's first, so I need to put that first in the equation. But look at the equation. It goes y minus y1, so the y value is always last. So the last number in the ordered pair is the first number you're going to write into the point slope formula. The first number in the ordered pair is the last number you're going to write in the point slope formula. Well, anyhow, from there, what we do is use that distributive property. We're going to multiply -5 over that subtraction, and then also change any minus negatives to plus positive. Well, from that point, we can rewrite what we've got left over here. Y plus 23 equals -5x, and then plus 20. There's another common mistake. Negative times a negative makes a positive right here. Well, we just have one final step there, and that is to isolate y. So I'm going to subtract 23 from both sides. And when I do that, I've got y by itself. So now my answer is y equals, and I've got -5x, and then minus 3. So there it is. That is my equation in slope-intercept form. Well, one more example here, and it goes this way. Well, this time, when we go ahead and substitute our numbers in there, we're going to end up with not a whole number, but a fraction. So let's see what we end up with, what our fraction ends up looking like. Same thing as before. We're going to end up taking our y values, and we put those on top of the fraction. So a common mistake is sometimes people just take the point and they subtract 7 minus 8. But we take the y values and put the y values on top. So I have 8 minus 6. Now down below, we're going to take those x values. So again, the x values are the first numbers in the ordered pair, but they go on the bottom of the fraction. So since I started with the 8, I got to put the 7 underneath the 8. So 7's going to go here, and then it's always minus, and then I take this -7 here, and that goes second right in that spot. So minus -7. So the common mistake I see with this is when people are adding the opposites, they just change one of the parts, plus, or maybe they change the wrong number. They change the 8 to a negative, but it's always adding the opposite. So you change subtraction to addition, next number to its opposite. Same thing here, plus positive. And so when I do that work, I end up with a -2, or a positive because I'm more positives than negatives, positive 2 over a positive 14. So I can go ahead and reduce that fraction, and 2 goes into both of these numbers, so I'm left with 1/7 as the final slope. So again, I divided by 2, I divided by 2, I reduced that fraction, so the slope equals 1/7. Well, I can now take one of those points and that slope that I just found and put that into my point-slope formula. So it doesn't matter which point you take again. I'll take this one this time. Take the 7 and the 8. They go in for x1 and y1. So I'll rewrite what I've got. Y minus 8. Remember, the second number goes first, is the first number you write in the equation. And then equals 1/7 times x minus, and it's always the first number, it goes last in the equation, minus 7. So we go ahead and do the work, use that distributive property, 1/7 times x and 1/7 times 7. And when we do that, we end up bringing down that y minus 8, but it equals 1/7 x minus 1. Well, sometimes people get a little confused. How'd you get that 1? Well, here's what I did. I did 1/7 times by negative 7 over 1. See, negative 7 is the same thing, or minus 7, same thing as negative plus negative. See, that's how I can treat it as negative 7 over 1. And then you can see how those 7's cross-cancel, and you're left with negative 1. 1 times negative 1 makes the negative 1. Well, from that point, the only step we have to do to get y by itself is to do some opposite operations. So I'm going to add 8 to all sides. And what I'm left with is this. I've got a y equals 1/7 x plus 7. I had opposite signs here, so I had to subtract those two numbers. And that's why I ended up with a positive 7, because there's more positives than negatives. And so those are some of the examples that types of problems that you'll end up seeing on tonight's homework. Part 2 will go over a word problem that involves the same concepts we're using here.